the chapter Units and Measurement. The next bit is Derived Units. So we already learned about fundamental units and their supplementary units. Now what is derived unit? The derived unit can be defined as any physical quantity which are derived from the fundamental by multiplication or dividing them is called derived physical quantities, and their respective units are called derived units. The example for derived units are: one is speed. Speed is one of the physical quantity which is derived from the fundamental. How it is? So it is the ratio of distance by time. So the distance is measured in terms of meter and time in second. The unit is meter per second. Next one is velocity. Velocity is also one of the physical quantity that is defined as the ratio of displacement to a time. So displacement is measured in terms of a meter. Meter is a fundamental quantity. Time is in second. The unit is meter per second. The speed and velocity are the two physical quantity which has the same unit, meter per second. So displacement is nothing but distance between the minimum distance between 2 points. Distance is the path traveled by the person from point A to a B. That is nothing but distance. Displacement is the minimum distance between 2 points. From after that, so some of the derived units are listed here. First one is force. Force. The derived unit is Newton and symbol is capital N. The next one is work and energy. Work and energy are the two physical quantities. So its unit is joule and symbol is capital J. Next one is power. So the unit is watt. So symbol is W. Fourth one, electric potential. The unit is volt. The symbol is V. Fifth one is electric capacity. The unit is farad. The symbol is F. Sixth one, magnetic flux. The unit is Weber. The symbol is WB. In this case, power, we are going to use only W. In this magnetic flux, W and small d, Weber. So magnetic flux is one of a derived physical quantity, and unit is Weber. Derived physical quantity. The first one is force. Force can be measured as it is a product of mass into acceleration. Mass into acceleration. So mass is measured in terms of kg. It is a fundamental one. Mass joule per second. So 1 joule per second is equal to 1 joule per second is equal to 1 watt. So watt. Now the physical quantity. The next one is electric potential. It is defined as V is equal to W divided by Q. So electrostatic potential is defined as work done in bringing a test charge from infinite distance to a certain point. That amount of work done, you can call it as electric potential. So it is measured in terms of volt. So work is in joule and charge is in coulomb. Therefore unit is joule per coulomb. Joule per coulomb. So 1 joule per coulomb is equal to 1 volt. Okay, this is electric potential. Next to that, electric capacitance. Electric capacitor. Electric capacitor. Okay, that is nothing but charge by potential difference. Charge by potential difference. We know that charge is measured in terms of coulomb and potential difference is in volt. So charge in coulomb and potential difference is in volt. So T, which is nothing but capacitance of capacitor. So electric capacitor. Electric capacitor. So 1 coulomb per volt is equal to farad. 1 coulomb per volt is equal to farad. This is a derived SI unit for electric capacitor. Farad. Keep in your mind. Derived unit for electric capacitor. Next one is magnetic flux. So this is one. So sixth one is magnetic